Hello and welcome to Azure's Live Mert to the Future. Today we are going to talk about serverless in Azure, and I have a very special guest, Vaibhav Gujral. I hope I have pronounced it correctly. And hello and welcome to Azure's Live.
Hello, thank you. Thanks for having me.
So how are you?
I'm doing pretty good. If a very good morning, good evening, good afternoon to everyone who is joining us, depending upon whichever time zone you are in. Really excited to be part of this show. Thanks, Matt, for having me once again.
You are welcome. So before we start, can you please introduce yourself, your community activities, your user group?
Sure. So my name is Vaibhav Gujral. I'm based out of Omaha, Nebraska, which is in Midwest United States. I'm a cloud architect working at Kivit Corporation. I am awarded Microsoft Most Valuable Professional Award in Azure category. I do run Omaha Azure User Group, which is a community of local users who work on Azure. We crossed 1,000 users in Meetup recently, and I'm a Microsoft certified trainer. I do love talking to people. Do love uh, speaking at different events, user groups, and conferences, and really looking forward to this presentation today.
Me too. So shall we start?
Sure thing. Let's get started. All right. So, hey everyone, welcome once again. Today, as Mert was saying, we are going to talk about how to get started with serverless in Azure. Just a level setting here. I have planned around 60 slides for next 1 hour or so. I'll cover some of the different concepts, primarily focused on Azure functions and logic apps and how you can get started with serverless in Azure. Before we jump start with the actual topic, I did introduce myself. Just a snapshot again. As I said, I do run Omaha Azure User Group. I have listed the link over there. If you are interested, do check out the link. We do conduct bi-weekly meetings. We have been virtual so far, hoping to get back to in-person meetings, but we'll be in a hybrid mode so that if you want to join on Teams, you can. I do work as a cloud architect at Kivit Corp, which is one of the top construction companies in the United States. I'm a Microsoft Azure MVP and a Microsoft certified trainer. And I have been in Omaha, Nebraska since 2016. Before that, I was based out of India. I have numerous Azure certifications from security engineer to DevOps engineer, solutions architect, developer, administrator, and so on. And with that, I think that's pretty much about me. Let's jump onto the agenda. Today, we'll start with very basic on what is serverless, what are the different serverless offerings that we have in Azure. We'll touch upon Azure functions and Azure logic apps in little depth. Then we'll also touch upon SQL database, Cosmos DB, and Kubernetes services in Azure and how we can enable serverless offering in those services. To start with, very basic, what is serverless? Serverless has been a hype word in last few years. It's been one of those coolest things that I have come across after cloud computing became mainstream. And to be very clear, it could actually be a very misleading term. Literally, when someone says serverless, it can be translated into something which has no servers, which is partially incorrect because serverless workloads do run on servers. They do need servers to run. So it is very misleading to say that there are no servers. How I see is, instead of saying as no servers, see serverless as less of servers. You don't have to really worry about the underlying server management. You don't have to worry about infrastructure and operating system because they are all provisioned for you on demand for the execution time. Whenever your code is executed, your server, your operating system, your infrastructure, everything is provisioned for you on the fly and decommissioned as soon as your execution is completed. Now, it's also important to understand some of the benefits that you get out of serverless architectures. To give you an example, most of us would have come across situations where you would have deployed resources on a hosting platform, and you would be maintaining that server component up and running 24 hours, so that whenever the actual request comes in, your server can process that request and respond back. Now, the challenge is your server might not get requests 24 by 7, but you were running your server components 24 by 7, and that increased your cost. So, and just to handle requests at a specific time, you were just running those resources 24/7. So in serverless, as the resources are provisioned on the fly whenever your code gets executed and deprovisioned as soon as the execution is completed, it essentially removes that need for running those resources 24 by 7, and you don't really need to retain those always on resources so that you can handle your requests. So that's a major benefit that I see out of serverless components. Uh, if you have heard of something like Azure Function, AWS Lambda, Google Cloud Functions, that's one of the specific use cases of serverless architecture known as function as a service. What function as a service essentially reflect is you can run your independent code pieces as individual functions, and Azure Functions is offered by Microsoft. AWS Lambda is the AWS offering, and Google Cloud Functions is Google Cloud offering. They essentially are pretty similar in concept. Another use case for serverless architectures are integration platform as a service, where you can actually run your workflows in a serverless mode. And one of the examples is Azure Logic App, which we are going to touch upon today as well. So before we really start jumping onto specifics around functions and logic apps, I just wanted to touch upon the different serverless offerings that are available in Azure today. And Microsoft has been adding serverless features to many services on a regular basis. To start with, as I was saying, serverless Azure Functions is a serverless offering in Microsoft Azure, where you can run your independent code, units of code as functions on a serverless infrastructure. Then is Kubernetes. Microsoft has a specialized platform as a service offering for Kubernetes known as AKS. You can run your AKS instances on what are known as virtual nodes in a true serverless mode. You can run your databases like SQL databases and Cosmos DB in a serverless mode, so that you can save on your database pricing. You can also run your workflows based on logic apps, which we are going to touch upon later in this presentation. You can have serverless API management. You can use something known as stream analytics for serverless analytics. And this list has been growing. You can check out Microsoft documentation for up-to-date list on what all different services do support serverless infrastructure. Let's jump onto Azure Functions and see what Azure Functions are. As I was saying, Azure Function is an offering from Microsoft, which lets you run your code on demand. I personally call these small pieces of codes as functions, because if you come from application development background, you might understand what a method is or what a function is. And essentially, you can take those functions and methods and run them as independent units of code inside Azure Function. So just imagine that if you're writing a code for a problem at hand, then you can write that code without worrying about the whole application or infrastructure to run it. You can write your code, you can deploy that code as an Azure function and test it and deploy it and test it and move on. So which I believe is so critical, because essentially it gives you independence to run your code as well as execute it on demand, which is very interesting, and it's not dependent on any other functionality or any other component in your application. Now, Azure Functions do provide different out-of-the-box templates for some of the most common scenarios, like you can connect to storage, Azure Storage. You can do things like image processing. You can do things like exposing your APIs using HTTP triggers. You can utilize it for IoT use cases. You can run custom scripts as part of your Azure Functions. You can respond back to an event as part of your Azure Function code. The possibilities are immense. Now, Azure functions really come in pretty handy in some of these listed scenarios, but these are just some of those, and there are different other scenarios where you can utilize Azure functions. And you can actually boost your development team's productivity through Azure functions, because as I was saying, you can run these pieces of code independently and execute it on demand. Your development teams can actually work on independent functions and work and deploy them and test them. And another advantage you get is if your development team has different skill sets, your developers can work on functions written in different programming languages and independently deploy them and test them and still integrate them as a single application.
I have questions. Which programming languages does it support?
I have a slide on that. It does
Okay.
supports multiple languages like C Sharp, PowerShell, and so on. So I have in next two slides, I'm going to touch upon different languages that it can support. So good question, Mert. And before I move on to the next slide, if any one of you have worked on Azure App Services in the past, uh, there is a feature known as Azure Web Jobs, which lets you run background jobs within the same context as your web app. So essentially, Azure Functions, think of it as an serverless evolution of your Azure Web Jobs. In fact, if you will go and look into Azure Functions SDK or Software Development Kit, it essentially utilizes Azure Web Jobs SDK. So, as Matt was asking there, the different languages that Azure Function supports include C Sharp, F Sharp, JavaScript, Java, PowerShell, Python, and TypeScript. And this list has been growing. It all started with C Sharp originally, but Microsoft has been adding more and more languages to the name to Azure Function Service. And just in case if you have a language which is not supported by Azure Function, you can use something known as a custom handler. If you can execute your piece of code in your programming language of choice over HTTP. I'll show you in the demo how you can connect that. And since it is serverless, one of the features of Azure Function is you only pay for your execution time. You only pay for the time your code is executed. Your resources are provisioned for that time and then deprovisioned whenever the code is executed. The execution is over. It does support NuGet and NPM packages. And if you have been using, we'll touch upon what a trigger is, but there is a specific kind of trigger called HTTP trigger through which you can trigger your Azure function as an API, as an HTTP API. And if you are using that specific kind of trigger, you can actually utilize OAuth for authenticating your API calls. Since Azure functions are part of Azure ecosystem, they offer seamless integration with other Azure services. We'll touch upon what different Azure services that Azure functions can be integrated with. And it does offer flexible development environment, as I was mentioning in my last slide too. If there are different developers with different backgrounds, they can still work on Azure functions using their own programming language of choice, and they can still work together and deploy as part of the same application. And lastly, Azure Functions Runtime is open source. It's available in GitHub. You can go and check it out and contribute if you're interested. So Azure Functions Runtime is what really powers running your Azure functions in Azure. You can actually set up Azure Function Runtime locally too, so that you can test your Azure functions locally and see how they work before deploying it to Azure. There are essentially two different components. One is the management role. The other one is worker role. Management role sets up your function environment, and worker role lets you run your actual function code. So there are three different versions available for Azure Functions Runtime. It started with 1.x, 1.0, then moved on to 2.0, then it's now in 3.1 or something. But the difference is, starting with 1.0, it was based on .NET Framework 4.6. That's why it was not cross-platform. But starting with version 2.0, it was built on top of .NET Core. So it's cross-platform. You can run it on different operating system, just not on Windows. You can run it on Linux and Mac OS too. Here's the detailed support for different programming languages. It supports F#, Java, PowerShell, Python, TypeScript as well. As you can see, starting with 1.0, it only supported C#, JavaScript, and F#, but starting with version 2.0 onwards, it does support the rest of the other languages too. So as I was saying, Azure Functions offers seamless integration with different Azure services and different third-party services too. As you can see towards the bottom, the different sample of different services that you can possibly integrate your Azure Functions with. This is just a list, minimum list of the services. There are many other services that you can integrate your Azure Functions with. Starting with, you can integrate your Azure Functions with Cosmos DB, Event Hubs, Event Grid, Service Bus, Storage Accounts, IoT Hubs, and many other Azure services that can be integrated with your Azure Functions. Apart from those, you can also integrate with third-party services like Twilio for SMS integration. You can also integrate it with SendGrid if you want to have email integration with your Azure Functions. You can integrate your Azure Functions with Kafka, with Dapper. You can also integrate your Azure Functions with webhooks and trigger your Azure Functions whenever a webhook gets called. So very powerful, offers integration with so many different services, makes your job so much easier. Moving on, it's important to understand how an Azure function works. It all essentially starts with an event which triggers a function. And as I was saying, it does supports integration with several Azure as well as third-party services. So whichever service you integrate your Azure function with, whenever there is an event that happens in that particular service, it essentially triggers your function. So if you take an example of Service Bus Queue, you can essentially integrate your Azure function with a Service Bus Queue, and whenever there is a message written in your Service Bus Queue, it is registered as an event, and it can trigger your Azure function. You can also use Azure Blob Storage, where you can trigger your Azure function whenever someone uploads a document or an image in your Blob Storage. You can also use something known as a timer, recursive timer, which can trigger your Azure function on a schedule regularly. So what essentially happens is, as soon as an event gets triggered, it actually triggers your function execution, which executes your code, the code that you have written inside your Azure function. And once your code is executed, it returns the output to the whichever Azure service or any other service you want to integrate with, and take the output from the Azure function. Couple of concepts you should be aware of in Azure function is triggers and bindings. As the name suggests, triggers is the entry point for your Azure function. It triggers your Azure function execution. There are out-of-the-box templates that you can use to trigger your Azure functions. As I was saying, there is a trigger for blob, through which you can trigger your Azure function as soon as a blob is uploaded. There is a trigger for Service Bus Queue. As soon as a message is written, it triggers your Azure function. And all those triggers are offered by Microsoft out of the box. It's just built into the runtime. You can utilize them and by providing the connection strings to your services. Do note that a function can have exactly one trigger. You cannot have more than one triggers for your Azure functions. And as I was saying, examples might be blob trigger, Service Bus Queue trigger, HTTP trigger, timer trigger, and so many other triggers it supports. We'll touch upon them shortly as well. Likewise, triggers, there is another thing known as binding, which essentially lets you connect your Azure function to different other services, Azure as well as third-party. Bindings help you access data from those services and send data back to those. And bindings can be input or output bindings, or they could be bidirectional as well, in out. Function, unlike a trigger, a function can have multiple bindings because a function can integrate with multiple services at a time. It can talk to a blob as well as queue. And for a trigger, you also have to define a binding for a trigger, which is always of the direction in, because it always captures the information and passes it to the Azure function. When you're writing your Azure function, I have taken an example of C# here because I come from C# background, but it's essentially true for any of the other programming language that you are going to use. But when you start developing an Azure function, it essentially has two main components. One is the code that is written in the supported programming language in your Azure function, and the other component is function.json file for defining your triggers and bindings and storing any of the additional information. So what you are seeing here is a C# example. Here I have written a function which is returning a person object. I have defined my function with the function name attribute. And here is where I have defined that it's a queue trigger. My function gets triggered whenever a message is written into my queue, and I'm returning back my person object into a table storage. And here's the example of my function.json file where I have defined my trigger as well as my binding. My trigger is defined as queue trigger, and I have provided the name of my queue and the connection string. And then I'm also providing the binding for my output variable. As you can see, name is defined as written, indicating this is an output variable. And I have provided the connection string to my table storage as well as the name for my table storage. To get started with developing Azure functions, I've taken an example of C# here. If you are a Visual Studio developer, you can get started in Visual Studio 2019 if you have Azure Development Tools installed as part of your Visual Studio installation. If not, if you have not installed it earlier, you can go back and modify your installation and ensure that you have Azure Development checkbox checked, and it will ensure that it has appropriate tooling for Azure functions installed on your system so that you can get started with the development. So once you have that, to verify if you have it or not, if you will go inside and try creating a new project, in Visual Studio 2019, you will see a template for creating an Azure function. If not, you have to go and modify your installation. If you are a Visual Studio Code developer, you can go ahead and install an extension known as Azure Functions, which is offered by Microsoft, which lets you develop your Azure Functions using Visual Studio Code. If you are a Visual Studio Code user, to debug and test your Azure Functions locally using Visual Studio Code, apart from the extension that I was showing you in the last slide, you also need to install Azure Function Code Tools, which lets you run and test your Azure functions locally. And it comes with different versions, version 1.0 and version 2.0 and 3.0. And similar to the runtime, version 1.0 was built on .NET Framework, and hence it was supported on Windows only. But starting with version 2.0 onwards, it's built on top of .NET Core, and it is cross-platform. It's supported on just not Windows, but also on Linux and Mac OS. Quick touch upon Azure Functions pricing. So when you create an Azure function, there are 3 different pricing plans that you can opt from. To start with the consumption plan, which is the truly serverless plan, where you are charged only for the time of your execution. You are not charged for a single penny if you don't execute your code at once at all. And it's the default hosting option when you are creating an Azure function. By default, the hosting plan that is selected is consumption or serverless. There were different challenges with the consumption plan. One of the major challenge has been cold starts. What happens is when between different executions, if there is a gap, the function might go into sleep mode or become idle. And the next time your function code is executed, it might take a little while to get triggered and that problem is known as cold start problem. And I have personally seen that problem, especially with blob triggers. What happens is whenever I have a blob triggered function and I want to trigger my functions whenever I upload a file in my blob storage. If my function goes idle, it might take up to 10 minutes sometimes for my functions to get triggered once they go into idle mode. So which was not ideal. So what to solve that problem, Microsoft has announced premium plan, which is built on top of consumption plan, but essentially it always keeps a perpetual warm instance running, meaning at no time your single function instance will be killed. Your single function instance will always be up and running so that the problem of cold start can be resolved. And there are some additional benefits that come with the premium plan as well. Apart from solving the cold start problem, you can also connect your functions to virtual networks, and there are some other benefits that come with premium plan. And then the last one is the dedicated plan, which is similar to an Azure App Service plan. You can run your Azure functions inside an app service plan. Do remember, when you are running your function in an app service plan, do remember to check the always on option to prevent the cold start problem. The crux of the discussion on pricing is how do you decide between consumption versus premium or app service plan. Essentially, there is a break-even point at which you should move towards dedicated or app service plan. So what I'm trying to show you here is, let's say I have an Azure function for which I only see executions during daytime, and I don't see any executions during nighttime. And if I move to a consumption plan, the benefit I get is I don't pay a single penny for my night hours because I don't have a single executions during night hours. And even during day hours, I only pay based on the number of executions. So as you can see, it's only during 10 o'clock when I see my executions maxing out, and I might be paying more than a dedicated plan during that time. But for rest of the times, my executions are not towards the higher side that I should move into a dedicated plan. So essentially what happens in a consumption plan is there is a component running in Azure known as a scale controller. What it essentially does is it keeps a track of the incoming events, and it accordingly scales up or down function host instances. Now you have to understand the difference between function host and a function. A function host or a function app is a combination of different functions. You can run multiple functions inside a function app or a function host, and that function host or a function app essentially is the scale unit that the scale controller scales up or down every time based on the incoming events that is being monitored by the scale controller. So all those individual functions that sit inside a inside a function host are actually managed, deployed, and scaled as a single unit. I'll show you how you can add multiple functions within a single function app shortly. And last but not the least, function host or a function app actually provides the execution context for your functions. But I'll show you that as well in my demo. Here's a project structure. The moment you go ahead and create your Azure function, you create your Azure function app. And then within your Azure function app, you can go ahead and create multiple functions. And as you can see, there is a file known as host.json, which holds all these configuration settings for your function host. And then for each of the individual functions, apart from having the code, you can also have function.json, which defines the function specific configuration settings and triggers and bindings. Let's quickly jump onto Azure portal and see how we can get started, how easy it is to get started with a creation of an Azure function. I'll go ahead. I already have a resource group created. I'll go ahead and click on create a resource. I'll go and look for function app, click on create. I'll go ahead and give it a name, my demo function. I'll go ahead and choose a runtime. I'll choose .NET, but you can choose any of these based on whatever your requirement is. You can also opt for custom handler just in case if you are using a language that is not supported by functions and you would like to utilize custom handler for that. I'll go ahead and choose .NET here. I'll keep the version as 3.1. I'll keep the default region. I'll keep the storage account name as is, but you can choose an existing storage account or you can create a new one. You can choose operating system as Linux or Windows based on whatever programming language you are using for your function app. I'm going to stick with Windows for now. And here's the different plan types that you can choose from. You can choose from a consumption plan, premium plan, or an app service plan. And as I was saying, consumption is your default plan that you can that comes with your function app.
By the way, I think he didn't like your function name.
Sorry.
And can you please go back?
Oh yeah. Thanks, Ron. Thanks, Mark. Okay, so I'll go ahead with consumption, but you can choose any of these plans based on whatever your requirement is. You can go ahead and enable app insights for monitoring your Azure functions. I'll go ahead with the default option. Obviously, you can go ahead and disable if you don't want that. You can provide any tags that you would like to tag your function app with. I'll go ahead and review my settings and go ahead and create. It will take hardly few seconds to provision my Azure function, which is provisioned in a consumption plan. I'll go ahead and go inside my it's still deploying.
And while we are waiting, I have a question. I couldn't see .NET 5.
Sorry?
I couldn't see .NET 5 on the runtime selection, only .NET 3.1. Is there a specific reason it is not supporting .NET 5 yet?
I think it's not supported on consumption plan yet, but I can verify that for you. Give me a second. Yeah, good point. I know they announced the support for .NET 5 in Azure Functions recently. So if I go here and choose Functions and choose .NET, strange, I was seeing version 5 because when I'm developing in Visual Studio Code, it does gives me an option for .NET 5. Interesting. I'm not sure why it's not showing up here, because if I go here and not here, right here. C#. Here it's giving me an option for .NET 5. So that's interesting. I didn't realize that it's not giving me an option for 5. You can check it out right now. It might have to do with my subscription too, because it went GA in March. So probably that is something I have to go and check why it's not showing up here for my application.
Okay.
Or it might just be with my, I'm not sure. Good call out. I'll check it out and let you know later what's going on with my subscription, why I can't
Okay.
see it in Azure portal. But here's my Azure function app. This is the function host that just got created, which is the single scale unit that the scale controller scales up or down. I'll go into the functions tab here. As you can see, there is no function right now in my function app. I'll go ahead and create a function. I can certainly go and develop it in Visual Studio or Visual Studio Code, or I can use any other editor of my choice. But for now, I'll go ahead and start developing it in Portal. It gives me option to choose any of the available triggers. I'll go ahead and create with an HTTP trigger, but you can choose any trigger that is as per your that works for a requirement. I'm going to give it a name HTTP trigger. I'll leave the authorization level as function, but there are different options you can choose from. You can either authorize at the each individual function level. You can keep it at anonymous, or you can keep it at the function app level. I'll keep the authorization at the function app level for now. And I'll go ahead and create the function in Azure portal. And here is my trigger, which is being created here, function which is being created here. I'll go and pull up my code and see what it did. It basically created a boilerplate code for me. What it essentially does is it's looking for a name in the query string, and it's returning based on whatever value I'm providing here. You can go ahead and customize here whatever you need, but you will notice it has it is in a file known as run.csx, where csx refers to C# script file, which is an extension on top of C# that you can utilize here to write your C# functions. I'll show you how you can do the same thing in your Visual Studio too. But anyways, I'll go ahead and click on test and run. I'll pass on the default value that it's passing. I'll click on run. Now it's running the same Azure Functions runtime in Azure to run my Azure function. So as you can see, it did execute it and it did return the value. I can close this. Let me quickly jump onto Azure to in Visual Studio 2019 to see how is the experience in creating an Azure function there. Since I already have Azure Development Tools created, I can see a template for Azure Functions there. I'll go ahead and give it a name, my function app, and I'll click on create. And as you were seeing in Azure portal, it gives me an option to choose any of the available triggers there. I'll go and choose HTTP trigger. One thing you will notice here is it asks me to choose a storage account here. Since I'm creating it locally, I can either opt storage emulator to test and run my code locally, or otherwise I can certainly go ahead and choose existing storage account in my subscription and link it with my Azure function. And the same authorization level, the three options that it was giving me in the Azure portal, I will stick with the function. I'll go and click on create, and it essentially creates the same boilerplate code for me that it created in Azure portal. If I go ahead and run it here, it will start the same Azure function runtime that you were seeing in Azure portal. Now it's running locally on my system. I'll go and capture this. Oops. Let me go ahead and run this again. Since it's an HTTP triggered function, it gave me this URL. I'll go here and run this. So it says I should pass a name inside my body. So I'm going to pass a name as Azure-ish. Here you go. And if I go into the function runtime, you can see that it executed the function twice. So pretty cool, pretty easy to get started with Azure Function in Visual Studio 2019 or in Azure Portal. You can get the same experience. As I was saying, you can go ahead. You need in your Visual Studio Code, you need to have certain extensions created, installed on your Visual Studio Code environment. For this particular demo, I already have the extension for. Oops. I have already installed the Azure Functions extension. I have also installed Azure Core Tools, which you can get it from here, which lets you, these Azure Function Core Tools lets you locally debug and test your Azure functions. Anyways, I did also install Azure account extension, which lets me sign in into my Azure account. That's why I'm able to see my different subscriptions here and the different functions I have. I can certainly go ahead and create an Azure function from here. I will go ahead and click on create a new project, choose a location for my project, and VS Code. I'll select this, choose C#. I'll choose .NET Core 3 for now. I'll choose HTTP trigger. I'll choose the default options. I'll keep company function as the namespace. I'll keep function as the authorization, and I'll open it in the current window, and it will essentially create same boilerplate code for me, which I can certainly go ahead and edit it. Since I have Azure Function Core Tools installed on my system, I can actually go and test my function locally in Visual Studio Code as well. So here you go. My function is now exposed on that HTTP API. And I can go ahead and see if it's up and running or not. Oops. What's happening? Oh, I think it stopped running. Let me go ahead and run it again. There you go. I'm installing the wrong API. So as you see, it's pretty easy to get started with Azure functions in whichever development tool you are using. I'll stop debugging. And as you can see, I was saying it is based on Web Jobs SDK. That's why you will see those namespaces being included in your function file. Now, if I go back to Visual Studio, as you will see, this is my function app. It has a single function right now, but I can certainly go ahead and add multiple functions here. New Azure function, and I can choose, click on add, and I can choose a different trigger. This time I can possibly have one with timer trigger. When I use timer trigger, I have to provide the schedule in cron syntax, which lets me run my function based on a specific schedule. I'll click on add, and it adds a different function. So what happens is when I run this particular function, it runs every 5 minutes and executes whatever code is there in my function. So likewise, we can have multiple functions in our function app, and we can deploy them as a unit. If you're deploying it through Azure, through Visual Studio Code, it's pretty simple. It's similar. The experience is pretty much similar to how you will publish a web app. You can choose Azure to publish. You can choose which app function app you want to deploy. Let me choose this, and you can choose the appropriate function app where you are deploying to. And if you are using Azure DevOps or any other DevOps tool, you can use those as well to deploy your Azure functions. So pretty easy experience to get started with. One another concept I want to touch upon before talking about logic apps is known as durable functions. There are certain scenarios where Azure functions might not be ideal choice. For example, if you are trying to implement complex workflows using Azure functions, like you have function 1, which is calling function 2, which is calling function 3, you cannot have workflows like that because essentially Azure functions are stateless in nature. They don't generally maintain any states between different functions. and that might cause problems. And also Azure functions are perfect when you have shorter execution times, like within few minutes. It's perfect, great, it works great, but the moment your execution times increase, your workflow execution time increases, Azure functions are not probably the best choice. So what solution Microsoft came up with is what is known as durable function. So durable function is an extension on top of Azure functions, which lets you write stateful functions in a serverless environment, meaning you can implement those complex workflows in a stateful way. And it essentially, what it does is it creates three different category of functions in your durable functions. It starts with client function, then is an orchestrator function, and then is an activity function. So client function is the function which is an entry point which gets triggered based on an event, similar to what you have seen in an Azure function just now. You can trigger your client function using HTTP trigger, blob trigger, queue trigger, or any of the other supported triggers. Then a client function calls an orchestrator function, which is the magic behind durable function. And orchestrator, as the name suggests, orchestrates your complete workflow. It can execute multiple activities based on different patterns that we'll see shortly. So essentially, you have your client function which gets triggered, which is in turn calls an orchestrator. Your orchestrator can call multiple activities. Your orchestrator can also call a nested or a sub orchestrator, which in turn can call its own set of activities. Durable functions has gone through multiple versions, iterations, and starting with version 2.0, they also support something known as an entity function, which lets you state your durable entities, your entities in a stateful way. I have a slide on that. We'll touch upon that shortly. On top of Azure functions, if you will notice, for durable functions, there are new trigger bindings that you can use to implement your durable functions. As you can see, I am showing an example here for a client function, where, as you can see, I have function name as queue start. I have a queue trigger indicating this function gets triggered whenever there is a message written into my queue. But I also have an additional binding known as durable client, indicating it's my durable client function. Then if you will see, my durable client function is calling a method known as starter.start a new async, which essentially calls an orchestration function. And my orchestration function, as you will see, is named hello world here. And here is my hello world function, and I have decorated it with orchestration trigger binding, indicating this is an orchestration function. And then within my orchestration function, I can call multiple activities, and if I have activities, I can decorate my activity functions with activity trigger attribute, as you can see here. There are different patterns that you can implement using durable functions, starting from function chaining, meaning you can chain execution of different functions in a sequence, meaning function 1 calls function 2, function 2 calls function 3, and function 3 calls function 4. You can also integrate storage in between your function execution, like storage accounts or SQL databases. You can also implement a fan out, fan in pattern, as visible in this second screenshot, where you can execute multiple functions in parallel and then wait for all those functions to finish and then call your next function in line. You can also implement durable functions using a pattern known as async HTTP APIs patterns, where if you have long running actions triggered by an HTTP call, like what you are seeing is a start function, which just triggers your workflow and returns back status 200 to your or status accepted status to your caller. And then your caller can keep polling your workflow using a get status function to get the current status of your operation. Another pattern you can implement using durable function is a human interaction pattern. Sometimes you might need a human to interact with your workflow, and in such situations, you can actually utilize human interaction. Another pattern you can implement using durable functions is monitor pattern, which refers to a flexible recurring process in a workflow. Most common example is when you have to keep polling a certain system until certain conditions or certain event happens. And as soon as that condition is fulfilled or that event happens, it can then trigger your other Azure function. Here is the entity function that I was talking about, which were introduced in .NET 2, Durable Function 2.0. Entity functions, in a nutshell, lets you read and update small pieces of state, which are known as durable entities. Similar to how I was showing the attributes that the bindings that come for durable function, the specific binding that you need to use for entity function is entity trigger, highlighting it's an entity function. And they are just available in Durable Function 2.0, so do check it out. Very powerful. You can store your small pieces of state explicitly. I mean, in durable functions, it also supports statefulness, but that is all done in memory. But in entity functions, you can store that state explicitly. Moving on, just keeping an eye on the time. Let's talk about Azure Logic Apps quickly. Azure Logic Apps, as I was mentioning in the initial slides, it's an integration platform as a service offering under Azure. It lets you schedule, automate, orchestrate your tasks, businesses, and workflows. You can utilize Logic Apps for different scenarios like application integrations or system integration. You can utilize it for EAI or enterprise application integration scenarios or B2B scenarios. Similar to Azure Functions, Azure Logic Apps also comes with several ready-to-use built-in and managed connectors, as well as you can also write your own custom connectors to make them super easy to use. In a nutshell, an Azure Logic app contains 4 different components, starting with connectors, which essentially lets you build workflows to process and integrate your information across different environments. You can connect your on-premises and cloud systems to your Azure Logic apps through connectors. Connector offers 2 different things, triggers and actions. Triggers, as I was mentioning about Azure Functions as well. Trigger is something that triggers your workflow. Trigger is something that triggers your Logic app. Initially, a Logic app used to support only one trigger, but now if you are creating your Azure Logic app in a specific way, you can support multiple triggers, just not one. I think the max number is 10. And then based on that trigger, you can perform certain actions. For example, if I trigger based on an Outlook trigger, whenever I receive an email, I can perform certain actions on my email in my Logic app. And lastly, since we can have multiple actions within my Logic app, I can also utilize what are known as control flows to create the workflow out of my triggers and actions. Just to give you a snapshot of how it looks like, in any Azure Logic app, you use connectors. Connectors is a combination of triggers and actions. Triggers kick off your Logic app workflow, and actions are what you execute, are actual units of executions in your workflow. And before I jump into benefits, you can also create your own custom connectors, though Logic app does provide many built-in and managed connectors for most of the common services, but you can still go ahead and create your own custom connectors if there are no available connectors for the service you are trying to integrate with Logic app. There are several benefits you get out of Azure Logic apps. It does comes with a UI-based designer. I have a slide on that later, but it helps you if you are a no-code developer, you can essentially go ahead and create a Logic app purely in UI designer without writing a single line of code. It does support, as I was saying, support for enterprise integration and B2B scenarios. You can, and it's all serverless. You pay only for what you use. You are only charged for execution time and not for the time when you are not executing your Logic. I'll touch upon pricing and hosting options in one of the later slides. Touching upon triggers as well quickly, as I was saying in functions 2, trigger is something which is essentially kicks off your workflow. It's the entry point for your Azure Logic apps. And actions are the steps that follow your trigger, and you perform different tasks in your workflow using actions. There are two different kinds of triggers that you can utilize as part of your Azure Logic App workflow: polling trigger and push trigger. As the name suggests, in the polling trigger, it regularly polls a specific service or a system based on a specific schedule, and it always keeps on checking if there is a new event that has happened in that source system, or if there is a new data available in that source system. As soon as one of those conditions happen, the trigger automatically runs your logic app. Whereas in the push trigger, the trigger waits and listens for new data or an event to happen. It doesn't keep polling the system though. And whenever the data is available or whenever a new event happens, the trigger actually creates and runs a new instance of your logic app. Speaking of connectors, there are two different types of connectors that are available that are provided by Microsoft, though you can also have your own custom connectors apart from these. But the ones which are provided by Microsoft, there are classified into two categories: built-in and managed. The major difference is built-in connectors run natively on your Logic App runtime, and they don't need a separate connection resource type in Azure to work, whereas the managed connectors need a separate connection resource type, which helps which actually makes the connectivity happen between Logic App and the other service. Managed connectors comes in four different forms. On-prem connectors, as the name suggests, helps you connect to your on-prem resources. Enterprise connectors provide access to your enterprise systems. Integration account connectors support B2B scenarios. And ISE or integration service environment connectors are a small group of connectors which are specific for ISEs. I will talk about what ISE is in one of the later slides. Here's a quick snapshot of the different built-in connectors that you can use as triggers. To start with, there is a schedule trigger, which lets you run your Logic App at a regular schedule. You can have something known as HTTP trigger. Similar to Azure Function, you can trigger your Logic App over HTTP. You can have an Azure Function trigger. You can trigger your Logic App based on an Azure function. You can integrate it likewise using several other triggers for different other Azure services. Several other standard connectors are available through which you can connect your Logic apps with different other services, not just specific to Azure, but outside Azure too. You can connect your Logic app with Azure Service Bus, SQL servers, SharePoint, Salesforce, Office 365, storage accounts, event hubs. You also have connectors for FTP, SFTP, and so on. There are numerous on-prem connectors that you can utilize to connect your on-prem systems, ranging from Oracle to Postgres to IBM, DB2, MySQL, and so on. Several enterprise connectors you can utilize with your Logic apps range from IBM 3270, IBM MQ, and SAP. Here are certain control workflows that I was saying you can utilize within your workflow to execute different actions, starting from condition, which is similar to an if condition, where you can evaluate a condition and based on the result, you can execute portions of your workflow. You can have iterations in your workflow using for each or until. You can use switch case, switch, similar to how you can utilize conditions and so on. You can terminate your workflow based on a certain condition using terminate. You can also utilize data manipulation connectors for performing operations on data. Starting from data operations, you can perform operations like parsing your JSON or parsing your CSVs or parsing your XML. You can parse different category of data. You can parse your HTML, and whenever you have to manipulate or you have to read and manipulate your data, you can use the data operations. Likewise, for performing operations on date times, you can utilize date time connector. And another last important piece here is variables. Sometimes in your workflow, you might need to store value just within your workflow, use them, and then discard those values. You can utilize variables for that, where you can initialize a variable with a value, set a value to that variable, use that variable in your workflow, and then discard at the end of the run. Before we talk about the hosting options for logic apps, it's also essential to understand the difference between stateful and stateless workflows. If you're creating essentially stateful workflows, you can keep, review, and keep your data from previous events and refer it in the next set of runs, whereas in stateless, you don't save anything from your previous events. So stateful workflows really come handy when you are trying to debug. You can go and look into your previous run history for your logic app, whereas that's not present in stateless. But why do you need to understand stateless versus stateful is because there are different hosting options that has been announced for logic app. It all started with the multi-tenant hosting option, which was known as consumption, which was truly serverless. You were only charged for your execution time, and it didn't supported any VNet connectivity. You can only had one workflow at that time in your consumption plan, and the resources that were allocated to your logic app were shared across multiple logic apps running across multiple tenants. Then recently, Microsoft has announced a new hosting option for a single tenant hosting option for logic apps called as standard, which essentially lets you run your logic apps within an app service plan. The benefit you get out of it is you can actually run multiple workflows now inside a single logic app. And it does support, since it runs on app service plan, it does support different connectivity options like you would have seen for app services for connecting your logic apps to virtual networks and so on. And all the workflows that you create within your single logic app are the only apps that share your underlying resources under standard one, unlike the consumption one. Now, there were scenarios specifically where you needed isolated environment to run your logic apps. In those scenarios, you could have utilized what is known as integration service environment. That was launched as part when consumption logic apps were also available. Like consumption ones, they also support only single workflows, and different logic apps that you were running in your ISE, they used to share the resources that were allocated to your ISE. Just a note there that if you are using ISC, you can there are certain connectors which are only available for integration service environment. You can essentially identify those using either core or ISC listed under the connectors when you are creating a logic app. For B2B or enterprise integration scenarios, you can essentially implement your workflows through logic apps as well. You can create what is known as an integration account, then you can add different partners and agreements and artifacts to your integration account. You can then create your logic app and hook up your logic app to your integration account, and then build your logic app with the artifacts, which if you have come from B2B background, you will understand how this process works. It's pretty straightforward. But if you are using integration account connectors, these are some of the ones which are supported by logic apps that you can utilize for your enterprise integration or B2B scenarios. To get started with Azure Logic Apps, if you are developing it in Visual Studio 2019, you need to install an extension called as Azure Logic App Tools for Visual Studio 2019. If you are using Visual Studio Code, there are two different extensions you need to use depending upon which plan you are using, which hosting option you are using. If you are using consumption, you need to install Azure Logic Apps Consumption. If you are using standard, you have to use Azure Logic Apps Standard. When you are creating an Azure Logic app, there are two different ways you can create. It could be a UI designer, which is a completely no-code designer. You can design your workflow completely in a UI, or you can also use a JSON-based designer where you can define your Logic app workflows. Before I jump onto a quick demo, if you are someone who have experience with Power Automate, you will notice very large number of similarities between this UI designer that comes for Logic App and the designer that comes for Power Automate. So there are some specific differences between the two different services. Logic Apps are targeted for IT professionals or developers, whereas Power Automate is targeted for power users or citizen developers. Logic App does support different scenarios like B2B and enterprise integration, which is not supported by Power Automate. There is no code-based designer available for Power Automate. Azure Logic Apps are part of Azure ecosystem, whereas Power Automate is part of Power Platform. Azure Logic Apps does support continuous integration and continuous delivery, whereas Power Automate does not because it's completely SaaS. With that, let me quickly go to my machine and show you how you can get started with an Logic App how you can create a Logic App quickly in your environment. I'll go inside my resource group, search for Logic App in Azure portal here. Let me go ahead and search for Logic App. And as you'll see, it will give you two different options. You can create under consumption or you can create under standard. I'll show you creating both. I'll first go ahead and create a Logic App consumption. I'll give it a name, consumption LA. I don't want to run it in integration service environment, but if you want to use an ISC, you need to first go ahead and create an ISC in your environment if you want to run your Logic App in an isolated environment. In this scenario, I don't want to, so I will just uncheck that. If you want to send your runtime logs from your Logic App into a Loganalytic workspace, you can enable this option. I don't want to do that right now. I'll go and click on Review plus Create. I'll create my Logic App. Likewise, by the time this comes up, let me go to another tab and create a standard Logic App too, so that I can show you the difference between two. Go inside here, create Logic App, and this time I'll choose standard. So I'll click on create. I'll give it standard. And I'll keep workflow. I will choose an hosting option for me. It gives me an option right now for app service plan. Probably it's not supported in the region I'm trying to create, but I'll go with this default option that it gives me. As you can see, pretty similar to how it shows for app services when you're creating an app service. I'll keep the default option. I'll enable app insights and by default, and I'll review and create my standard Logic App too. So I'll come back to the consumption one and see what's happening in my consumption Logic App. As you will see, since I'm opening my Logic App for the first time, it shows me a template. It shows me a start screen where I can go ahead and opt from built-in or different templates that Microsoft offers, or I can start with a blank Logic App as well. What essentially you are seeing here is I can get started with a trigger that they list some of the most common triggers that I can opt from. I can certainly create a blank Logic App, or I can also go and create a full Logic App workflow based on certain templates, most common templates. So in this example, what I'm going to do is I'm going to utilize HTTP request response template. I'll use this template and it will automatically create a workflow for me. I'll go ahead and click on save. It will go ahead and create a URL. And this is pretty much how my Logic App initially is being created. What it essentially does is, if I'll go to the designer, whenever a HTTP request is received on this particular URL, it triggers my Logic App, and then it returns back the response. But you can certainly go ahead and add different actions. Click on plus sign here. You can add an action. And here are all the different connectors that I was mentioning. You can find all different connectors here and see the supported actions. For example, If I want to perform an operation on SQL Server, whenever my logic app gets triggered, I can call these many different actions. I can execute a SQL query, execute a stored procedure, and so on. Pretty neat, pretty easy. If I go back to my standard logic app, it has a different experience though. If you remember, this was the experience I was showing you for my consumption logic app. If I want to go back to my designer, here is how I can go. I can switch between my JSON code view or between my designer view. Whereas in Azure logic app in the standard mode, the experience is pretty much similar to an app service. Within my standard logic app, I'll go inside workflow. I'll go ahead and create on add. It gives me an option to choose stateful versus stateless. I'll just go ahead and choose stateless for now. I will give it a name stateless and click on create. It created my workflow, and this experience now to create my stateless workflow is pretty much similar to what you were seeing in my consumption logic app. It gives me a designer view as well as a code view. So I can go ahead in my designer and I can choose any of those built-in connectors that I had. I'll go ahead and choose HTTP, and I'll first add a trigger. I'll choose an HTTP trigger. So whenever an HTTP request is received, I want to go ahead and add an action. So I'll go ahead and choose HTTP and respond. Not this one. Oops.
May I ask a question?
Yeah, go ahead.
Is it possible to use the design view on Visual Studio or VS Code, or should I use Azure Portal?
No, it's possible to use it in Azure, in Visual Studio as well. I'll show you shortly.
Okay, thank you.
So as you can see, the pretty much same experience that I have created the same workflow that it created for me in the consumption logic app. I can create it in the new ones. The only difference you should notice here is I can add multiple workflows here inside my single logic app inside the standard tier, whereas that's not possible in a consumption tier. But again, consumption is what makes it truly serverless. I pay only for my executions, whereas if I'll go inside my standard, you will see it has a fixed service plan created for it, which has a fixed cost for it. I can certainly go and scale it up and down, similar to how I can manage it for my app services. I can go ahead, as Mert was asking, I can pretty much go ahead in Visual Studio and create a logic app. So I'll go ahead and click on create a new project, and I'll go ahead and search for Azure Resource Group. I'll click create. And when you are creating using a template for Azure Resource Manager, because essentially logic apps and the consumption were part of ARM templates, whenever you go to Azure portal, and if you will see in the code view, it essentially is JSON. And when you are trying to export template for that, let me go to the resource group to give you better clarity. If I go here and export template, you will see the same JSON for my logic app gets included in my ARM template. It's generating. So here you will see, here is my since I have multiple resources. Here's my logic app. So you will see the logic app actually shows up here in the JSON, the same format that we had in the JSON. This is the one that I was showing you, the same JSON that you create in the code view shows up in your ARM template. That's why you have to use the template for Azure Resource Manager in your Visual Studio to get started. Once you will choose that template, there is an option for logic app there. Go ahead and choose that. Once you will click OK, the experience is exactly same what you were seeing in Azure portal. If you will go ahead and right click your logic app.json and open it with designer, it essentially gives you the same experience that I was showing you in Azure portal. And I can essentially go ahead and choose any of these available templates, or I can go ahead, let's say, delete old Azure blobs. It will give you the same experience that you have here. Likewise, if I go in Visual Studio Code, I already have extensions installed for my logic apps. If I will see here, I have my logic. This is my logic app that I got created. You can certainly manage your logic app here. You can enable, disable. You can open it in designer here, and you can see what's in there. You can edit it the moment you will go ahead. And let's say if I return 201 here instead of this is, I'm not able to edit it here. I guess I have to edit it in editor. So if I go ahead and edit this to 1 and click on save, it automatically asks me to save and ask me to upload my changes to Azure. So I can always select always upload, so that whenever I make changes to my logic app workflow, it automatically pushes my changes to Azure. I'll just click upload and it will go ahead and deploy my logic app changes to Azure. Likewise, you can also go ahead and create a new logic app within Visual Studio Code. You can choose the subscription, the resource group, the location, my logic app, and it will create the code view. And once you have that, you can deploy it in Azure as well. Pretty decent experience working on logic apps. But do be aware of the two different development experiences that are offered by Microsoft now, one in consumption, one in standard. Consumption is serverless. Standard is where you can run your app service plans and run your logic apps inside an app service plan. And you can run only a single workflow in consumption. You can run multiple workflows in your standard one. Moving on, serverless is also offered under databases. To start with, serverless offering in SQL databases. When you are provisioning your Azure SQL databases, do remember to check the option for serverless when you are trying to provision your SQL database in serverless mode. Be aware that when you are provisioning your SQL database in a serverless mode, you have to provide certain parameters, starting with the min vcores and max vcores, which defines the auto scaling range for your database. So what happens is, if your database is not consuming any resources, you will be billed for minimum vcores. But when your database starts consuming resources between minimum vcores and max vcores, you will be charged for based on whatever the actual consumption is. And then you also have to provide what is known as auto pause delay, what you are seeing down there. What essentially it does is it helps to defines the period of time the database must be inactive before it is automatically paused. Because under serverless, what essentially it does is, if it's not there are no executions, it just pauses the database so that you don't incur any costs. Similar to Azure SQL databases, there is an option for serverless in Azure Cosmos DB too. You can, while you are provisioning your Cosmos DB, you can choose the capacity mode as serverless. What essentially it happens under serverless is you don't have to specify provision throughput, which is measured in request units in Cosmos DB. And you are charged based on the execution. Then it allocate specific request units to your Cosmos DB as and when they are needed, and then you are billed for those in serverless. Similar to other services, Azure Kubernetes Services also offers a serverless offering. If you intend to use in your Kubernetes cluster, do remember to enable virtual nodes when you are provisioning your Kubernetes cluster. So essentially, virtual nodes lets you deploy or bust out containers to the nodes backed by ACI, which is Azure Container Instances. So basically, you can bust out different containers as an on the fly whenever the execution requires that level of resources. So yeah, with that, I know it was pretty fast. I was moving very fast. Serverless in Azure is big topic. They have been adding different features to it. I hope this would have been helpful to folks who want to get started or understand how they can get started with serverless in Azure. So, Mert, do you have any questions for me?
Yes, first of all, thank you for your presentation. It was a great presentation that whenever I wanted to ask a question, you already gave me the answer. I want to ask about the learning materials. As all of us know, the MS Docs is a great place and MS Learn. But do you have any recommendations to learning Azure Functions or Logic Apps?
Yeah, Microsoft Learn, I believe there are certain learning paths. I don't have a slide for that for learning resources here, but I would probably pass it on to you. I'm not sure if you can post it on the if you can post it on with the video, but if not, I can probably recommend that you should start with Microsoft Learn or Microsoft Documentation is the best source of truth to start with. I would recommend those two.
Okay. Thank you very much again, and hope to see you again in further episodes with different topics.
I'm sharing my contact information just in
Sure.
case if anyone wants to reach out to me. If you have any questions around serverless, feel free to reach out to me. I will be more than happy to answer any questions that I can.
Okay. So thank you very much, and hope to see you again.
Yeah, thank you.
Thank you.
Thanks for having me.
You're welcome. Cheers.